Hi everybody. In this video I'm going to explain series and parallel circuits. We learned before if we have two series resistors, R1 and R2, and they are connected in series with a voltage source. So the total resistance would be equal the sum of the resistor, R1 plus R2, and the current flowing in this circuit will be the same. It means the current flows in R1 is the same current flows in R2, and the voltage will be divided among the two resistors. If we have two resistors connected in parallel, R1 and R2, and they are connected in parallel, so the current will be divided. Here we'll have I2, here we'll have I1, and the total resistance RT will be equal R1 times R2 divided by R1 plus R2. Today we are going to have combination of both series and parallel. Let's just take one example here and see how we calculate the total resistance. If we have resistance here like R1, and we have another two resistors, R2 and R3, and another resistor R4, and connected to a voltage supply E. So what is the total resistance in this circuit? Well, when we look at this circuit, we can see that this resistance R2 and R3, they are connected in parallel. So the first thing we're going to do, we're going to simplify the circuit. Let's just give values for these resistors. So let's say, for example, that this resistance is equal to 30 ohm, and this equal 20 ohm, and this equal to 40, and that's equal to 60 ohm. All resistors are given in ohms, and let's say that the voltage is equal to 120 volts. So the first thing we're going to do, we're going to simplify the parallel combination, and we'll find the equivalent resistance for both of them. How can we do that? We are going to use the parallel formula just did here. Will be the product of the two resistors divided by the sum of the two resistors. So the equivalent resistance of the parallel combination here will be equal to 30 ohm times 20 ohm divided by the sum. That will be equal to 600 divided by 50, which is equal to 12 ohm. So we can replace the two parallel resistors by one resistance, which is equal to 12 ohm. We'll just go ahead and put the equivalent resistance 12 ohm and complete the circuit. We have in the top resistance R1, which is equal to 40 ohm, and we have in the bottom R4, which is equal to 60 ohm, and we have the voltage power supply, which is equal 120 voltage. Now we look for the simplified circuit. We can see now that the 40 ohm, 12 ohm, 60 ohm, they are all connected in series. Why? Because if we assume there is a current flowing in 40 ohm, it's the same current flowing in 12 ohm, it's the same current in 60 ohm. The current is not divided, the current is the same. So we can say now that the total resistance of this circuit is equal the sum of all of them, 40 ohm plus 12 ohm plus 60 ohm. That will be equal to 2, 16, 17, and 4, 11. We'll have 112 ohm. So you can say that now the whole circuit now is reduced only to one resistor, which is equal to 112 ohm, and one voltage supply equal to 120 volt. So if you would like to find the total current in the circuit I total So you will say I total is equal the voltage E divided by 112 ohm. The voltage E is equal to 120 voltage. So that's 120 voltage. And the total resistance 112 ohm. So let me use my calculator to find the value. So 120 divided by 112. So you get 1.07 amp. So that will be the total current of the circuit. So that's a simple problem here to find the total resistance, and we use the combination first. So always we look at the circuit and we try to find easy combination and then simplify the circuit, and we continue in the simplification process. Okay, let's take one more example. Let's have we have one resistance here equal to 10 ohm and another resistance so this is 100 ohm and this is another 100 ohm. So when you look at this problem, well, from this side, then you can see that these two resistors are connected in parallel. Why? Because the voltage across this 100 ohm, it's the same voltage across 100 ohm. Since the voltage across both resistors is the same, so these two resistors are connected in parallel. And also you observe that they are equal. So it's easy if you have equal resistors, two equal resistors, so the equivalent will be E divided by 2. So you can say 100 ohm divided by 2 is equal to 50 ohm. Somebody will say, okay, why don't I use the same rule that we did last example? He says you can do, but it will take longer time. Say 100 times 100 divided by 100 plus 100. So you get 100 times 100 divided by 200, then cancel two zeros, then you'll get in the end is equal to 50. All right. So just easier if you have two equal resistors divided by 2. What about if you have three equal resistors connected in parallel divided by 3? So in any way, these two resistors connected in parallel 100, I can replace only by the equivalent. It's equal to 50 ohm. So I have now 50 ohm. And I have one resistor here in the top, 10 ohm. And I have, let's assume that we are going to have voltage equal to 300 voltage. So that's equal to 300 voltage. Now, you look at the circuit, you will see 10 ohm is connected in series in 50 ohm. Why? Because the current is the same. The current flowing in 10 ohms is the same current flowing in 50 ohm. So you can add the two resistors, 10 ohm and 50 ohm will be 160 ohm. So you have 160 ohm. 60 ohm, and the voltage here you have 300 voltage. Now we can calculate the total current. How we calculate the total current? You say the total current is equal to the voltage, which is equal to 300 voltage, and you divide it by 60 ohm, and you get 5 amp. In this problem, I'm going to find the current everywhere. So I will write the answer here is equal to 5 amp. So the current in the 60 ohm is equal to 5 amp, which is coming out of the voltage source. 5 amp, 5 amp. So 5 amp going in the combination. So I will write the current 5 amp. So 5 amp, it will be divided between the two resistors. And since these two resistors are equal, so 5 amp is going to be divided equally, so you will have 2.5 amp and 2.5 amp. And in this way we solved the problem. We found the equivalent resistor and we found the current in each branch. Let's take one more example. That's a resistance equal to 47 ohm. Another one, 47 ohm. $75 ohm, 68 ohm, 39 ohm, 100 ohm, and connect this to the ground. Connect this to voltage source E. In this problem, it's required to find the total resistor. Total resistance between the positive and the negative terminals of the battery. This is the battery, this is the positive and negative, so it means you want to find, let's connect the ground, so you want to find the total resistance from this point up to the ground, up to here. How can you see this circuit? So of course, the ground is just one point, so you can just do that to make it easy. You connect everything here by one line. You can make the simplification all connect out. So you want to find the total resistance between these 2 points simply. So what is the total resistance? If you want to only put one resistance between these 2 points, let's call them A and B. What is the equivalent resistance? Right. You can simplify by raising this one and just connect it to this line. Well, as we did previously, you just look at the circuit and try to find any combination, series or parallel, and simplify. When you look at that one, there is an easy one here. I can see it. I wonder if you can see it too. These two resistors, they are connected in series because the current the current flowing in 47 ohm will also flow on this one. So you can add 47 and 47. That will be in series. And you have another combination here. This resistance and this resistance, they are connected in parallel, right? So let's just finish this one. How you finish this one? They are in series. To do that, you are going to add 47 plus 47. But you see, when you have two resistor equal, if you have two equal resistors connected in series, you just can multiply by 2 instead of adding them. So there will be 2 times 47. So that will have 94 ohms. So you can replace these two resistors in series by one resistor equal to 94 ohm. Let's do that before we forget. Just to make it here a small one. That's we have 94 ohm. All right. About the parallel combination here, 68 ohm and 39 ohm, they are connected in parallel. Why they are connected in parallel? Look at these 2 points. When you look at the voltage across these 2 points, so we'll find out that the voltage across 68 ohm, it's the same voltage across 39 ohm. So they are connected in parallel. How you do the parallel? Use a parallel formula. You multiply. They are not equal, so you use the normal formula. 68 times 39 divided by the sum, 68 plus 39. I got to do that in my calculator here. Let me just do it. And 68 times 39 and divided by the sum, 68 plus 39. We get 24. I'll just round the number to one decimal, 24.8 ohm. So let's do that. So I have here the resistance 75. I'll just sketch it. 75 ohm, and the two parallel will be replaced by 1 equal to 24.8 0.8 ohm, and then I will close this one. Then the 100 ohm here just connected to in series with them, so you have 100 ohm. I don't have to sketch the battery, so these are the total on the fine. So now the circuit is simplified. More simplification is needed. So this resistor and this is not connected in series, obviously, because the current is the same in both. So what you'll do, you just find the sum of these two resistors. You are adding 24.8 to 75. All right, so just let me do it in my calculator. 24.8 plus 75, that's equal to 99.8 ohm. So that's the value of this resistor. So let's sketch the new circuit now. 94 ohm in the top, on the bottom I simplified to 99.8 ohm, and then I have another resistance which is equal to 100 ohm. This one I'm talking about. I'm getting closer. So you have two resistors connected in parallel, this one and this one. So what we're going to do, we're going to add them. So I'll say that's equal to 94 plus 99.8. Again, using my calculator here. So I have 94 plus 99. Oh, that's not series. Nobody just woke me up. They are connected in parallel. So I have to do the formula, the product 94. 99.8, and then you add them. They are in parallel because you have the same voltage. So use the parallel formula here. So let me redo it again in my calculator. The product 94 times 99.8 divided by the sum 94 plus 99.8, you get 48.4 ohm. So now the circuit is simplified to one resistor equal to 48.4 ohm connected in series with 100 ohm. So at last they are in series. So the total resistance will be equal 100 ohm plus 48.4. It will be equal 148.4 ohm. That will be the total resistance. All right. Let's take one more example. And this is important because it will be similar to the one you have in your class practice. You're going to do it in the end of the day. So you have one resistor here, resistor and then put the value on the ends. That's a good one. That's 10 ohm. 1 ohm, 2 ohm, 3 ohm, 6 ohm, and it's called A, B, C, D, E, F. And it's required to find the equivalent resistance. And of course, we can add, if you like, we can add the voltage supply here, E. Just let's focus now how to find the equivalent resistance. When it's required to find the equivalent resistance across AB, so you go from the other side, the opposite side, when you have this kind of circuit. So like series, parallel, like that, continuous series and parallel, like a ladder, you know. So you want to find the total resistance side. You start from this side. You start from here, the opposite side. That's a good strategy. You start from here. So when you look from here, what you'll see you have two resistors are connected in parallel. Use the parallel formula. So the parallel formula here, the product will be 3 times 6 divided by the sum will be 18 divided by 9. That's equal to 2 ohm. You sketch the circuit again and you put the equivalent. That's 2 ohm. And try to keep the same letter that you have. It will help you. That was E, F, that's CD, and that's 1 ohm, 2 ohm, 10 ohm. Well, and of course this is AB. Then you look at the circuit again. It's still working from the side, so you'll find that this is series circuit. So you add them 1 plus 2 is equal 3. So you draw the circuit and you do 3 ohm because the series 1 plus 2 is equal 3, and you got the 2 ohm here and 10 ohm. Keep that 3 ohm, that's equivalent between this point C, D, that's AB. Let's move. Then it's still looking from the side, and from the side you can see these two are in parallel. How you find the parallel combination? It will be like 2 times 3 divided by the sum. It will be 6/5, which is equal to 1.2 ohm. So you replace it by one resistance, 1.2 ohm. And he left 10 ohm. Now we can put the power supply. 10 ohm and 1.2 ohm, you add them, you have only one resistance. That will be equal to 11.2 ohm. And this is the power supply. So let's assume that this power supply equal to 112 voltage. How you find the current in every single resistor? To find the current in every resistor, you start backward. What do I mean start backward? Like you start with the last circuit you got, this one. So you have 112 voltage and you have 11.2 ohm. So you try to find the total resistance. Total resistance IT will be equal to 112 voltage divided by 11.2 ohm. Doing that, you get 10 amp. So the current is equal to 10 amp. So you go and you put 10 amp here. What does it mean? 10 amp flow in the 11.2 ohm. Or the current coming out of the battery, it's equal to 10 amp. So 10 amp now going through 10 ohm and also through 1.2 ohm. Go back to the circuit here. You have 10 amp flowing in this direction. Of course, you have the battery here. But now we have the current, so no problem. Let's make this clear. This is 10 amp, but it comes here, it has to be divided into two currents. How you find these two currents? Use current divider rule. How can you find current divider rule? For example, to find the current on this branch, you will say the total current going in this junction is equal to 10 amp. You write 10 amp. And then if you want to find the current in 3 ohm, you multiply by the opposite resistance, which is equal to 2 ohm. You multiply it by 2 and divide by the sum of both resistance, 2 ohm and 3 ohm. So you will have 20 divided by 5, that's equal to 4 amp. So you know the current here is equal to 4 amp. Once you find the current here equal to 4 amp, you can find the current in another branch. How can you find the current in the other branch or in 2 ohm? It's easy. You can use the current divider rule again. But why you are going to waste time? Because you know that you can apply Kirchhoff current law. What do you mean applying Kirchhoff current law? 10 amp is going in this junction, and then they went to 3 ohm, 4 amp only, so what's left? 6 amp. So you can just subtract to get the rest of the current going through 2 amp. So now we got 6 amp in 2 ohm and 4 amp in 3 ohm. You go to the circuit, because the circuit comes from this one. You put the values for the current in 10 ohm here, that you still have the 10 amp, and the 2 ohm in this circuit, 2 ohm, you have 6 amp, so you put 6 amp here, and the rest was here 4 amp. So 4 amp going through 3 ohm means going through 1 ohm and 2 ohm. And then you continue go to the circuit and above and put all this current that you got. So you have 10 amp, and you have in 2 ohm you got 6 amp, you put the 6 amp, and then you have in 1 ohm 4 amp, you put the 4 amp, and now there's a junction here, so again the current will be divided according to current divided rule. So we'll do the same thing to find the current in this branch. You will say the total current going to the junction before the split, you have 4 amp here, so you write 4 amp, and then since you want to find the current in 6 ohm, you multiply by the opposite resistance, which is equal to 3 ohm, and divided by the sum, 3 plus 6. So you have 3 times 4 is equal 12, and divided by 9. Simplify the circuit. By 3 is equal 3, by 3 is equal 4, so it will be equal to 1.3 amp. So the current here is equal to 1.3 amp. How to find the current in the 3 ohm here? Just subtract 4 minus 1.3 amp. So you'll have 4 minus 1.3 amp. That would be equal to 0.7 amp. So you got 2.7 amp. In this case, you found the currents in every single resistor. So simply what you will do, you simplify the circuit in steps, and you keep the circuit. Don't erase it, just keep it, because you will use it backward to calculate the current in every one. I hope that was helpful, and this is very close to the ICB that you're going to do after that. Try to solve the examples by yourself again, and then after that do your ICB. I hope you got it. All right, thank you, and we'll see you in another lecture.